Welcome back and Happy New Year for those who start a year in January. In today's video, we're discussing about the end-term evaluation of the course Intelligent Robotics taught in year 3 of Rwanda Coding Academy. But this doesn't concern only Rwanda Coding Academy's students. Everyone is concerned. Similar tests can be taken when you're looking for a job, when you're looking for an internship or a scholarship. Well, without further ado, let's get started. First question. This test or this evaluation is made up of two sections. Section 1 is made up of 10 compulsory multiple choice questions, while section B is made up of one question, which is compulsory. Let's start with section number 1, which is multiple choice questions. What's the primary purpose of the ANPR project? Is it object classification? Is it automatic vehicle access control using now plate recognition? Is it video compression in the storage? Is it lane detection for autonomous driving? It is automatic vehicle access control using now plate recognition. This is the purpose of ANPR project. Some may be tempted to select the correct answer as object classification, but object classification is too general. Let's go to the second question. Which key stages are involved in the ANPR system development? A. Data collection, model training, inference, hardware integration. B. Data cleaning, video compression, model deployment, communication. C. Image compression, segmentation, detection and classification. D. Video streaming, hardware optimization, and notifications. It's A. Data collection, model training, inference, hardware integration. Maybe some may be tempted to select B as the correct answer, data cleaning, video compression. But while data cleaning is in the first stages, there's no video compression involved here necessarily. And this sequence, data cleaning, and then video compression, model deployment, this clears the process. We don't start by cleaning, we start by collecting, and there's no video compression involved after data cleaning. If there was a video compression, it could have been before cleaning data. And you don't start by deploying the model, and where's the training, where's the inference. So the correct answer is A. And question number 3, why is data annotation important in ANPR workflow? A. To increase dataset size. B. To provide labeled data for model training. C. To visualize detected objects in the inference stage. D. To train the model without additional computation. The answer is B. The importance of annotation in the ANPR workflow is to provide labeled data for the model training. We don't want to do anything else but to provide labeled data for the model training. So the answer is B. Question number 4. Which AI model is used for NAPLET detection in this project? A. YOLO. B. TensorFlow Object Detection API. C. MaskR CNN. D. FastR CNN. We use YOLO. Five. What role does optical character recognition, or OCR, play in ANPR? A. Identifying the location of the vehicle, detecting NAPLET in an image, extracting characters from the NAPLET for further use, improving the resolution of extracted frames. The role of OCR is to extract text. That's what OCR does. It looks at the text in the image and it works to transform the text on the image into a text like any other text. Question number 6. What's the advantage of dividing the dataset into training and validation sets? A. Is it to increase the training speed? Is it B? Is it to evaluate the model's performance on unseen data? C. Is it to reduce the size of the dataset? D. Is it to simplify data annotation? It's B. To evaluate the model's performance on unseen data. By putting aside the validation set, we want the model to have a chance to test itself on unseen data. Then question number 7. Which parameter is adjusted during YOLO training to improve precision and recall? Is it learning rate, confidence threshold, batch size, data set size? It's learning rate. Let's look at the code in the train. Let's look at the line number 550. It's telling us about hyperparameter, and it says by default, it means if you don't specify the learning rate, it will by default consider a learning rate specified in this file. Where is this file? Located in data hypes, and the file is a YAML5 file. Let's look at this YAML file in data hypes, and this is the file. This is the file, and let's open the file with Visual Studio. In the file, learning rate is specified, and by default, the learning rate is 0.01. If you want to specify a different running rate or override it, as we say, you can specify it on the command you are issuing. For example, if you want, you can make it 0, 2, or 5, or whatever you want. Okay. So, question number 8. Why are LiDAR or ultrasonic sensors integrated into the ANPR system? A. Is it to capture video footage? B. To detect approaching vehicles and trigger the camera? C. To process video frames for non-plate detection? D. To enhance network connectivity for Arduino. That's for detecting approaching vehicles and triggering the camera. In your ANPR project, you don't have the camera to be on every time. You can pause your camera or sleep your camera and wake it up whenever an approaching vehicle is detected. Question number 9. What hardware component is essential for automating the gate mechanism in ANPR project? A. Microcontroller, example Arduino. B. Infrared sensor. C. Raspberry Pi camera. D. External GPS module. That's a microcontroller. Number 10. How is the YOLO 5 or YOLO version 5 model trained to recognize nameplates? A. Using a supervised learning approach on label data. B. By feeding unstructured video footage directly. C. Using unsupervised learning for automatic labeling. D. By applying pre-trained image classification models. It's A. Using a supervised learning approach on label data. That's what we've been doing. And now we can go to section B. Section B is made up of only one question, and it's a question that will require calculation. Not only calculation, but in our reasoning. You are evaluating an automatic number plate recognition, that's ANPR, model on a test dataset consisting of 100 images. The model has predicted bounding boxes for the nameplates, and you have the ground truth bounding boxes for all images. Now, a scenario. In one test case, the ground truth bounding box coordinates for nameplate are 50, 50, 200, 200, representing respectively X min, Y min, X max, Y max. The predicted bounding box coordinates are 60, 60, 210, 210. Sub-question A. Calculate the intersection of a union, IU, for this test case. Show your work step by step. Sub-question B. The model produces 200 predictions across the test dataset, out of which 150 are true positives, 30 are false positives, 20 are false negatives. Calculate the F1 score for the model using precision recall. Show your work. C. The model's performance across various IOU thresholds is given as follows. Map at 50 is at 5%. Map at 60 is at 3%. Map at 70 is 80%. Map at 80 is 75%. Map at 90 is 65%. Map at 95 is 50%. Calculate map at 50 to 95 at the average of all these thresholds. Show your work and explain its significance. Well, let's get started. Let's start by drawing. Even though drawing is not directly required, but the best way to do such questions is to start by drawing. Okay, let's try to be realistic and show you how this would look like. Let's say we have this NAND plate, and this NAND plate was labeled by, let's say this is one of the images, and this has been labeled by the engineer like you or me, and there is another rectangle drawn by a model during the evaluation. So this is the red rectangle, and there's a blue rectangle that you draw, and there is a red rectangle that the model draws. So let's continue the calculation. Let's continue answering the questions. The first question is IOU calculation. To calculate IOU, we taking the area of overlap. In this case, it's this area. On the other side, this is the total area. From this total area, we need to subtract the intersection area. So the calculation. This is what we are asked to do. And this is what we are given. And this has been clear when we explored the drawing. It's been clear. And now we can straight go to the calculation. The overlap top left corner is 60-60, and this is what we saw here. 60, 60, 64x, 64y. And overlap bottom right corner is 200, 200. On image here is 200, 200. Okay. So now we can calculate the overlap area or the intersection. To calculate the intersection, we of course need to take the width and multiply it by the height. And what is the width? The width is going to be 200 minus 60, same here. And the product is 19,600. And then we can calculate the union area. How? To calculate the union area, remember, we have to take the area of the ground truth plus the prediction, the area of prediction, then minus the overlap. So now that we have the area of overlap, and we can easily find the area of the ground truth, because the area of the ground truth can be calculated. We have 50, we have 200, then we have 200 minus 50, we have the width. We have it for the height, we have 200 minus 50, and that's for the ground truth. It's 50-50, giving us 22,500. And the area of prediction is found similarly. For the width, we take 210. 210 minus 60, giving us 50. Similar to the height, that's 210 and minus 60. Yeah, so they are the same, 22,500. Then we add them and subtract the area overlap found up there. And the calculation gives us 25,400. Okay. So now we can apply the formula. We have 19,600 over 25. This is the intersection or the overlap area over the area of union, and 77% or 0.2. That's the answer. That's the IOU. And let's go to sub-question number B. Let's calculate F1 score. Remember, we're given the true positives, the false positives, the false negatives. We are given all that in the question. They are given here. We have 50 true positives, 30 false positives, 20 false negatives. So the calculation is all about applying the formula. This is a harmonic mean. That means 2 times the ratio of product of precision and recall, or times recall, over the sum of precision and recall. So, and we need to come up with the precision through this formula, and recall through this formula, and true positives are given, false positives are given. The remaining is to just calculate. The trick here is to remember the the formula of F1 score. To remember that it's harmonic, and harmonic mean you have 2 times the product here, then the sum is the denominator. Okay, so the calculation is simple because you just replacing what you're given. And then some question C, we're going to calculate map at 50 to 95 map. Yeah, this is simple. This is given. So we have 6 values here, given 6 values. So we're going to look for a mean of these 6 values at different thresholds. And this is the formula. We're going to sum up the value at each threshold and then divide by 6, which is the number of thresholds. And we're summing up the thresholds, then dividing by 6. This is the map at 50 to 95. And it's going to be 53%. And to show the significance, you're going to talk about the value you find here. And look here. Just look here. Look how the ground truth, that's what an engineer, you or I, what we did, and what the model predicted. You see that it's only a slight difference. And it seems the model is not far from the ground truth. So you're going to discuss about this, but having the image in your mind, the picture in your mind, the model did it well. So in the result you find here, so this is a comprehensive measure of model performance, and it indicates its robustness in detecting objects accurately. You can see the accuracy in this image. You can see the model is accurate. If it wasn't accurate, it would maybe have drawn the bounding box far away, but it's close to what you drew. So this gives this shows the model is robust. Okay, so these are the answer, and this is where we end this evaluation. If there's something that you didn't catch very well, you can put it in the comment, and yeah, I will provide the answer or the clarification. Thank you very much. Let's see each other in the next video. Happy New Year!